Okay, so a very good evening to all of you. Uh, my name is Mohit teacher, and I welcome you all on the YouTube channel of TEQIPGATE classes. So this is all about me, and we were discussing about the unconventional machining operation. Okay, in the last lecture, basically we discussed yesterday. We discussed about the two of the numerical problem that is based on the metal cutting, and that has been asked previously in the engineering services examination. And before that, we have discussed two machining operations, non-conventional. That first one was the chemical machining, and the second one was the electrochemical machining. Okay, ECM. Today we are going to discuss about the electric discharge machining operation. Okay, but as in the last when we were discussing about the electrochemical machining operation, I gave you one of the homework problem. Okay, so that I want to discuss with you. Then we will move to the electric discharge machining. Okay, so let's start. Okay, so this was the problem, that is composition of a nickel based super alloy is as follows. The percentage, there are total 4 nickel based alloys is there, one of the super alloy, and there are total 4 elements. Okay, so first element is nickel, because this is the main component, this is the main alloy only. So the main component is 70%, means nickel is 70%, chromium is 20%, iron is 5%, and rest is titanium. So total is how much? That is 70 plus 20, that is 90, 90 plus 5, that is 95. So how much is remaining? Titanium, that is 5% is remaining. Okay, very good evening, Somaranjan. Actually I gave you that problem, this is in homework to you. Okay, so you asked the answer of this in the yesterday session, but I thought that today better we should discuss this problem, then we'll move to the electric discharge machining. Okay, so first we are covering that, then we'll proceed further. So titanium is how much? That is 5% is remaining. Calculate rate of dissolution, that is means we have to calculate the feed rate here. If the area of the tool is 1500 mm square, so the surface area is given to you. Okay, the current of 1000 ampere, means the value of I is given to you, is being passed through the cell. Assume dissolution to take place at lowest vacancy of the element. So first of all, if we have to calculate the feed rate, then what is the formula for the feed rate? That is material removal rate upon surface area. Okay, so surface area is given to you, we have to calculate the material removal rate. Okay, so how we can calculate the MRR, that is material removal rate? For that we have the formula, that is I into A upon rho into F into V. But here it is not a single material, there are 4 different, it's a nickel based super alloy. Okay, so 4 different elements are there. So what we have to do, and all for one of the problem that we discussed in the ECM, in which binary alloy was there, and for that density was given to you. But here all the separate densities is given to you, that is for nickel it is different, for iron it is different, chromium, titanium it is different, and this value is in gram per cc. Okay, gram per cc, please keep in mind. So we have to what we have to calculate, first of all, either we have to we cannot write a single density for that, so we have to go we have to calculate the E equivalent, as well as the density, the atomic weight and the valency for all the 4 elements are different, so we have to calculate the electrochemical equivalence for this. Okay, so how we can write this formula? This material removal rate will be equals to IA, that is I into E equilibrium upon rho equivalent upon F. Okay, so first of all, either we can calculate this value or we can calculate this value. So I am calculating this one first. Okay, so this E equivalent, so how we can calculate this E equivalent? That will be equals to 1 by E equivalent into x1 by e1, x1 by e1, तो मैं e1 को a1 और a1 v1 की टर्म्स में लिख देता हूँ. ठीक है, so this is x1 into v1 upon a1 ठीक है, into plus x2 into v2 upon a2 plus x3 into v3 into upon a3 plus x4 into v4 upon a4. ठीक है, तो all the percentage like we can, oh, there is a little bit light problem is there, but you can manage in this. Okay, so first one, that is x1, we are assuming that this is for the nickel. Okay, this is for the Fe, that is iron. Sorry, this is okay. This is for the chromium. Okay, this is for the chromium. This is 5% is Fe and this 5% is titanium. Okay, this you can consider for the titanium. Fine. Now x1 nickel is how much? That is 70%. So just put the value, that is 70% is, I am writing in point values. Okay, so this will be like 0.70 into v1. v1 is how much? That is 2 upon a1, that is a1 is what? That is 58.71 plus x2 is how much? x2 is that is chromium, so that is 20%, so this is 0.20 into v2 is how much? V2 is for the chromium, the density is 2 and the atomic weight is 51.99, so this is 2 upon 51.99 plus x3 is 5%, so 0.05 into v3 is for what? Iron. Okay, so this is for 2 and 55.85. okay, so this is 2, this is 55.85. okay, plus 0.05 into v4 is for titanium, so the valency is 3 and this is 47.9. okay, so this is 3 upon 47.9. okay, so please you calculate the value of E equivalent from here. Just I am coming into 1 minute. Okay, sorry for this disturbance. So E equivalent, yeah, right, Somalindan, it's 27.42, right, 27.42, right. So can we calculate the value of density, equivalent density? So for that it will be equals to 1 by rho equivalent equals to x1 by rho 1 plus x2 by rho 2 plus x3 by rho 3 plus x4 by rho 4. okay, so from here again the percentage is same, so this will be 0.70 first for the nickel, so density is it is 8.9. okay, yeah, this is 8.9 plus x2, that is for the chromium, so that is 0.20 upon what is the density, that is for the chromium, this is 7.19 plus next is that is 0.05 upon the density of third, that is 7.86 plus x, that is 0.05. okay, so what is the density for that? That is 4.51. okay, So from here you can calculate the value of row density. Row, that is row equivalent, that is density. So how much you are getting? Yeah, exactly. That is 8.069. But please keep in mind that that is in gram per cc. Okay, because this term is very very important here. This unit is very very important. Okay. Now, what we can calculate from here, that is MRR, that is material removal rate. So that will be equals to I. That is I is how much? That is 1000 ampere. Okay, this is 1000 into E equivalent. So we have calculated this value. So this is 27.42 upon what is rho equivalent, that is 8.069 into F. F is, if not given, then we are considering it is 96,500. So can you tell me the value of this MRR from here? This will be, yeah, right. This will be 0.0353 if I am taking in four terms. Okay. So this value will be in cc per second. Cc is semi cube per second. Okay. That was the terminology that we, when we were deriving this formula, that time we saw this terminology. Okay. So please keep in mind this unit. Okay. Now this is the MRR, but this is not a final answer. So we have to calculate the feed rate. Okay. So for the feed rate will be equals to, that is Fr will be equals to material removal rate upon surface area. Okay, so the material removal rate that we have recently calculated, this is 0.053. Now that is in cc. Okay, per second. Okay, this is per second. And what is the surface area? That is 1500. That is in mm square. Okay, so you can write this cc in semi cube. Now either you can convert this in this is in mm cube, or that one in centimeter square. So better we should go for this conversion. This is centimeter cube in mm cube. So what you have to do, 1 centimeter equals to 10 mm. So just multiply 10 raised to power 3. So this will be mm cube. Fine. This will be cancel out. What is remaining? That is mm per second. Okay. Now when you will what remaining, that is 0.353 into 1000 upon 1500. So when you will calculate, how much you are getting? Yeah, right. This is 0.0253. Okay, that is in mm per second. Okay, this is in mm per second. Now if we have to if we need the answer in mm per minute, so just multiply with the 60. Okay, so if you will multiply with the 60, then you will get the answer, that is 1.41 mm per minute. Okay, so this will be the feed rate. Fine. So question was little bit lengthy, but it was easy. Okay. Okay, so let's proceed for the main topic, that is today's main topic. So the content, first of all, I'm just briefing that what we are going to discuss in the EDM process, right? Yeah, right, Somaran, and that is 1.412 mm per minute. That's great. So today we are going to discuss about another machining process, non-conventional machining process, that is EDM, that is electric discharge machining. So again, from the first session only, when we started this non-conventional machining process, I said that these are the in these operations, basically we are not completely rely on a mechanical system, means mechanism and all these things are not completely mechanical, but we are using a combination because these processes are nothing but the multidisciplinary. Okay, so here to remove the material, we are using the electrical energy, and how this electrical energy is converted using the chemical energy and removing the material, that we are going to study in this EDM process. But like if you have completed like if you are in BTech, that's great, that I'm taking from the initial end to the end we will consider. But if you have completed, then also like generally engineering में क्या होता है, like we just university exam को clear करने के लिए पढ़ते हैं. So I assure you that it will give you a brief introduction about what we are going to that why this EDM process came into existence, okay, why we are using it, and this is the most important process of the non-conventional machining. Industries are using it. Okay, so let's start. So what is the content? Just I am briefing you first, then we'll go for the one by one. Okay, so first that we will study about the literature survey, that how this electric discharges came into existence and what okay, so why we followed that. Okay, next we'll discuss the principal part, then we'll go for the working, then after completion of this we'll go for the material removal, that when how the material is removed, and how this material, whatever the sludges is formed, not sludges, we cannot say sludge, but whatever the material is removed from the workpiece and the tool area, how it is coming out from that. What is the dielectric medium, means dielectric fluid that we are using here. What is the electrode material, means what are the functionality or the characteristics for the electrode material is required. Is again the same thing which is required for all the processes, that is material removal rate. Okay, so here we have to consider the mechanical as well as electrically. Okay, so modeling of MRR will make the model. Okay, and again there is a types of the power generators, means this is little bit electrical, but I just brief you about how many power generators are available that we can use for the EDM process. But most of the industries, those who are using this process, they are 90% of them are relying on the resistance and the capacitance circuit. So that we will discuss in the detail. Okay, there are three different cases are there, so that we will take in detail. Okay, from that there are formalized, there is formalized there. So numerical in the engineering services as well as in gate examination has been asked previously in that. Okay, and then we'll proceed for the numerical problems. So first of all, today I will try to cover up to here. Okay, and if you allow, then we can go for up to this as well. Fine, so let's start. So देखिए, ये मैंने जो थ्योरी लिखी है इसको मैं पढ़ूंगा नहीं. ठीक है, ये सिर्फ मैंने आपके लिए लिखी, that when you will get this notes. Okay, तो आपके पास ये सारी चीजें as per जो रिटर्न है, मतलब जो as per requirement है वो अवेलेबल है. ठीक है, so in the in the 1766, one of the chemist, or he as per chemist by profession, but he was a automotive engineer was too, Joseph Priestley. First, he discovered this electric discharge. Okay, and because he was as he was an automotive engineer, so he was just he's focused that whatever the cars that we are using. Okay, and in almost all the cars we are using the this DC power supply, batteries. Okay, so batteries are there. So by the way, functionality of batteries are many, like we have to use the lights, okay, different indicators, and okay, so one of the purpose is also that if it is a it has to generate this spark. Okay, whenever we will start the vehicle, that time it will generate this spark. So because of that only the combustion is started. So if it is generating the spark, then this is happened due to the power, means that DC power that we are using, means battery that we are using. So he just noticed that this there is a erosion of the craters. Okay, erosion of the craters at the cathode surface. मीन्स अगर आपने कभी पुराने व्हीकल्स को देखा होगा या फिर बैटरीज देखी होगी, पुरानी बैटरीज व्हीकल में, सो कोई एक पोर्शन होता है, बिकॉज वन इज एनोड एंड अदर इज कैथोड. सो कैथोड पोर्शन पे क्या होता है, द मटेरियल इज रिमूव्ड एंड जो व्हाइट या फिर ग्रीन कलर की शेडिंग्स जो होती है पाउडर फॉर्म में रिमूव होके वहीं पे सेटअप हो जाता है. सो दैट इज नथिंग बट द material removal. Okay, and I'm saying that there is a erosion of the crater. So erosion is nothing but the mechanism, wear mechanism only. and wear क्या होता है? Wear is the means once the material is removed, that only the wear, okay, because of the wear the material is removed from the workpiece area. So erosion of the craters occurs, okay, due to which, due to which the electric discharge occurs or the material is removed at the cathode surface, okay. So finally he started that arc can be used for the joining as well as for the machining purpose, okay. Then after like this was happened in 1766, but after 180 or 190 year, two of the scientists from the Moscow University, that is Boris and the Lazarenko, they basically received an assignment from the Soviet government, okay, after the Second World War, and they received basically an automotive engine that was critically damaged, okay, and they basically got an study. They were basically investigating the wear that is caused by the sparking between the tungsten electrodes, okay. So they found that they noticed that the spark can be used for the uniform and predictable means whatever the spark that is generated, that is more uniform and the predictable in the oil as comparatively with the air. देखिए spark और arc में क्या difference है? देखिए मैच बॉक्स जो होता है, लाइक मैच बॉक्स से एक स्टिक निकाल के जो हम जलाते हैं, दैट इज द आर्क, ओके. या फिर मान लीजिए कि आप वेल्डिंग जब हम करते हैं, तो वेल्डिंग जो मान लीजिए शील्डेड मेटल आर्क वेल्डिंग की बात करता हूं, तो जो वेल्डिंग कंज्यूमेबल इलेक्ट्रोड है और जो वर्क पीस है, दोनों के बीच में जो इग्निशन होता है, दैट इग्निशन occurs due to the arc, means जो resistance generate होता है, that resistance become very high and that time the arc is established. तो that is a arc, okay. Now जो लाइटर होता है, जो गैस में घर में जो किचन्स होते हैं, ठीक है, जो उसमें जो गैस के लिए जो हम जलाने के लिए लाइटर्स यूज करते हैं, so that lighter is basically generate the spark, okay. That is not the arc. So here basically he noticed that if we are using the spark, okay, in the on behalf of like जो हम lighters यूज करते हैं, that is for generating of the spark, अगर हम उसको एयर में ना यूज करके अगर हम उसको ऑयल में यूज करें, so we will get a more uniformity as well as whatever the direction that we define, it will be predictable, okay. So they basically after that they come up with the idea that if we are using the spark in a controlled way, then we can remove the material, okay. So after that only this picture came that through electric discharge we can go for the machining operation, okay. Now after this basically they were working, so they basically developed a circuit. We also call this circuit as a relaxation circuit, or it is based on the resistance and the capacitance, so we also call it as a RC circuit. Okay, this is RC circuit. Now what is this RC circuit is, or the Lazarenko circuit is? This is the Lazarenko circuit. देखिए again ये पूरा इलेक्ट्रिकल का है, तो I will try to explain you, okay, in a easiest way, ठीक है, ज्यादा आपको प्रॉब्लम भी ना आए, because देखिए मार्क्स अगर लेना है, so we have to study, okay. So this is the DC power supply, okay. This is the DC power supply. Negative side means the current is passes through this one. We are using one of the resistance, okay, resistor, okay. So the current is passes through that, and when it reach up to this distribution point, some amount of the current will go through this capacitor, as the capacitor, and some amount of the current will passes through this one, okay. Now in this side basically we are using this combination, okay. This is the tool, okay, and this is the workpiece. Now here just assume, but by the way we are keeping this workpiece and the tool in a dielectric medium, means fluid is there, so we are keeping this workpiece and the tool in that dielectric medium, okay. Now whatever the remaining current that passes through this one, and again this come to the junction point, and whatever the current that was coming over here, and again it will go to the DC power supply. So this is how the circuit is completed, okay. So this is basically the Lazarenko circuit, fine. Now अगर आप बुक्स में देखेंगे तो इसकी जगह टूल और वर्कपीस की जगह यहाँ पे कोई एनोड या फिर डायोड्स वगैरह भी बना के समझा सकते हैं, बट व्हाट आई फाउंड इज कि आप जितना इलेक्ट्रिकल एलिमेंट्स को कम यूज करोगे और मैकेनिकल को ज्यादा यूज करोगे, तो मैकेनिकल इंजीनियर्स को ज्यादा अच्छे से समझ में आएगा, ठीक है. सो दैट्स व्हाई आई यूज दिस वन, फाइन. सो नेक्स्ट इज द प्रिंसिपल. सो दिस वाज द लिटरेचर सर्वे. नाउ लेट्स मूव टू द प्रिंसिपल. सो व्हाट इज द प्रिंसिपल इज, if this is the tool, okay, means this is the connected with the power supply. Okay, this one is connected with the power supply, DC power supply. Okay, this is connected with the DC power supply. This side is connected with the negative side, means the cathode. Okay, and this side is workpiece is there, and we are making it as a anode. So that is the positive side. Now, when we'll create the potential difference, that time what will happen? That, by the way, everything is happening in a dielectric medium only. So right now, basically, I'm just introducing the principle. That's why I'm not adding that one. By the way, just assume that there's a liquid in between. Okay. So this is the tool. Okay, this is the tool, and this is the workpiece. Fine. In between the workpiece and the tool, यहाँ पे जो length दोनों के बीच का gap है वो बहुत ज़्यादा है, but actually it is very less. Okay, so this ऐसा मत सोचना कि इतना ज़्यादा रखना पड़ता है, then it is set up something. Okay, it's not like that. Okay, so what is happening that when we are creating the potential difference, at that time what happen, that this is the cathode. So what will happen at the cathode? It is a negative side, so that will generate the electrons, and workpiece, which is the anode, so that will generate the positive ions. So from this cathode, this negative ion electrons are generated. Okay, these electrons are generated. Now similarly happen at this one, the positive ions are generated. Okay, now these positive ions are generated. In between, as I said, that we are using the dielectric medium. So dielectric medium has the ions itself, dielectric molecules are there. Okay, so when these are ions are generating or the electrons are generating at the anode and the cathode respectively, so what will happen? ऐसा तो है नहीं कि बहुत सीधे साधे हैं, so जिस डायरेक्शन में आप चलाओगे उसी डायरेक्शन में चलेंगे. So they basically are moving here and there, means in random direction. So what will happen, that when these electrons will move toward this direction, these positive ions will move toward this direction, this will be basically they will move random. Okay, random in direction they move. So what will happen then, when they will collide with each other, the velocities increases. If this velocities increases, then it will reach to the maximum part, and is this velocity between this means colliding velocity, means क्योंकि collide हो रहा है एक दूसरे से, this if this speed is increases, this collision will increases. If this collision will increases, then the resistance is very high, and when the resistance is very high, they will basically generate this spark. They will generate the spark. Okay, this is the spark. Okay, now is once the spark is generated, now what we are doing is we are continuously supplying this current. Okay, we are continuously supplying this current. So what will happen, that once the spark is formed, is ऐसा तो है नहीं कि like all these are making together one spark. Apart from this also the other elements like electrons and positive ions are there, as well as molecules, dielectric molecules are there. So what will happen, they will also become a part of this spark, and they will generate the more energy. Okay, when they will generate a more energy, basically they start, because now what will happen, once the spark is formed, because spark is formed in between the electrode and the in between the tool and the workpiece. So now it will try to become straight, and this will follow, this will make a path. Okay, so this is nothing but, this is when in this basically is path, electrons are moving in this direction toward downside, and this positive ions are moving in upward direction. Okay, so this portion, whatever the column they are making over here, we call it as a ionized column. Ionized column. Okay, now this as this column is formed. Okay, so is okay, so now what will happen, that is this ionized column is formed. So what is happening in this column, the electrons and the spark is generated, and this spark is generated because of the very high velocity of the electrons and the positive ions. Okay, so what will happen, because of that because of the formation of the spark or the very high velocity, the kinetic energy of these electrons and the positive ions is increases. So electrons which are moving toward this side, and the positive ions which is moving toward this side, these basically hit this surface, hit the surface, this positive ion, this hit the surface of the tool, and this negative ion hit the surface of this workpiece. So when they will hit, this complete kinetic energy is converted into the thermal energy. This complete kinetic energy is converted into the thermal energy. Okay, and as it will convert into thermal energy, it generates very high temperature, and this temperature in the range of 10,000 degree centigrade. Okay, तो इसमें क्या होता है, 10,000 डिग्री सडनली जब जनरेट होता है तो मटेरियल जो होता है वो मेल्ट नहीं होता है, वो वेपोराइज हो जाता है. ठीक है, सो प्लीज कीप इन माइंड दैट इवेपोरेशन इज वेरी वेरी इंपॉर्टेंट. द मटेरियल इज रिमूव्ड in ECM. The material removal takes place due to the ion displacement, but here the material is removed from the workpiece area due to the evaporation. Okay, so that when this temperature become 10,000, and suddenly this kinetic energy is converted into the thermal energy, the material evaporates. Okay, so एक बार ये read कर लेते हैं what are the written over here. So in EDM, a potential difference is applied between the tool and the workpiece. As I said, using the DC power supply, both materials are workpiece and the tool are made up of the conductors of the electricity. Please keep in mind, I did not mention that one. Okay, so please keep in mind, the tool and the workpiece material are immersed in a dielectric medium. Everything is happened because of that only, because otherwise this will spread in the air. Okay, these electrons and the positive ions. Generally, the dielectric medium that we are using is kerosene or the deionized water is used as a dielectric medium. Okay, देखिए ECM में क्या था, ECM में हम लोग ये चीजें नहीं यूज कर रहे थे, because क्योंकि इनसे आयन नहीं बनते हैं, राइट. ओके, सो दैट्स व्हाई वी आर यूजिंग इट ओवर हियर, बिकॉज हमें डाइलेक्ट्रिक मीडियम चाहिए कि अगर मान लीजिए कि पॉजिटिव, अगर आपका आयंस जनरेट होना शुरू हो गया, सो व्हाट विल हैपन, दीस पॉजिटिव इलेक्ट्रॉन्स विल रिएक्ट विद दैट एंड दे विल फॉर्म अगेन द ECM प्रोसेस. ओके, सो दैट्स व्हाई वी आर नॉट यूजिंग दैट वन. A gap is maintained between the tool and the workpiece and through the servo mechanism. ये मैं आपको बाद में बता दूंगा अभी. ठीक है, so up to this is clear, प्रिंसिपल आपको क्लियर है. ठीक है, इसके बाद एक छोटा सा और पार्ट है कि लाइक हाउ दिस वंस दिस स्पार्क इज जनरेटेड, सो हाउ वी आर यूजिंग. सो इफ इट इज क्लियर देन वी शुड मूव फॉरवर्ड. Okay, fine, let's move. So depending upon the applied potential difference and the gap between the tool and the workpiece, an electric field would be established. ठीक है, electric field means arc is established. ठीक है, तो देखिए कुछ figures हैं through which I am trying to explain you that like initially plasma आपका you are using it, this is cathode negative side, this is anode, this is positive side, and जो अभी तक प्रिंसिपल हमने समझा लास्ट स्लाइड में, दैट इज कंप्लीटली डन एंड नाउ द स्पार्क इज फॉर्म्ड. ओके, देखिए स्पार्क, ये मैंने दो अलग अलग फिगर्स क्यों यूज किए हैं, इसका इसलिए यूज किया है बिकॉज देखिए एज आई सेड दैट के इन द बिगिनिंग इटसेल्फ दैट देयर इज नो कॉन्टैक्ट between the tool and the workpiece throughout the conventional non-conventional processes. Okay, जो इलेक्ट्रिक और केमिकल पे बेस्ड है. ठीक है, नाउ here is also, as I said, that spark is generated in between the gap. बट मान लीजिए कि जो आपका गैप है टूल और वर्कपीस का जो सरफेसेस है, दैट इज नॉट very means the surface smoothness is not that much satisfactory. Then what will happen, अगर irregularities हैं तो जहां पे contacts दोनों के बीच में कम है, वहां पर क्या होगा, सबसे पहले spark generate होगा. तो for an example मान लेते हैं कि this portion and this portion is contact to nearer to each other, so spark is generated there. As we move this one into downward motion, downward feed, because there is a servo mechanism is provided to the tool portion that we will discuss in the working part. So is it is moving downward side, so again whatever the next point that will come, because the irregularities is there, so that will come, like मैंने ऐसे assume किया है कि this portion is come nearer to after this one, so there it will generate the spark. So this concept is basically followed. Okay, so what we have to do is, if we have to go for the EDM process, then the surface roughness should be initially we have to manage. Okay, surface roughness जो है वो microns में होनी चाहिए, otherwise इफ इरेगुलरिटीज होगी, सो दैट वहां से क्या होगा, आपका मटेरियल रिमूव होना स्टार्ट हो जाएगा एंड इरेगुलरिटीज बन जाएगी, मतलब आपके अगेन डिसकंटिन्यूस कंटिन्यूटी फॉर्म हो जाएगी, ओके, बिकॉज ऑफ द इरेगुलर शेप एंड साइज। तो हम क्या कर रहे हैं कि वी आर जस्ट टेकिंग एग्जांपल that this is the workpiece, okay, so in this workpiece we have to use we have to make one of the semi sphere, okay, and here we have to make a conical shape, okay, means देखिए conical shape को जब हम front से देखेंगे तो एक triangle shape ही दिखेगा, ठीक है, so this is not a triangle but conical, okay, conical means circular है ऊपर से, ठीक है। So what we have to do is we have to make a semi-sphere over here and we have to make a conical shape. So what we are doing is initially we are keeping it inside the in container in which the dielectric fluid is there. Okay, and this is connected with the cathode side and this is connected with the anode side. Okay. Now once the potential difference is created, now we are moving this tool towards the workpiece. Okay, and just as हम workpiece को tool को लेके जाएंगे, that time this surface, okay, this surfaces will come in contact, मतलब इनके बीच में difference कम होता जाएगा in this workpiece surface, so that will basically remove the material. इनका okay, so जैसे जैसे आप you will move toward downward side, then the surface will remove, okay, so this surface, this, as you will move downward side, this gap will be minimized, so that will create the sorry for this disturbance today. So this gap is minimized as it become less, okay, so what we have to do, that will automatically start removing the material from that area, okay, so as like this is the second phase, okay, so this will how we will this material will remove, okay, so as we have to move inside, the material will come out and that will form the surfaces. देखिए इसमें क्या है कि अगर आप इसको देख रहे हैं तो इसमें क्या है कि मैंने थोड़ा इसको कांटेक्ट कर दिया है, मतलब ये जो कांटेक्ट है दोनों के बीच में वो उसको हटा दिया है, बट देयर विल बी सम गैप, ओके, ऐसा नहीं है कि इट विल बी इन कांटेक्ट, देयर विल बी सम गैप, ओके, देयर विल बी समथिंग सम गैप, ओके, इट्स नॉट लाइक दैट विल बी इन टच, फाइन, आप कंफ्यूज नहीं होना, ठीक है। सो दिस इज द प्रिंसिपल पार्ट, लेट्स मूव टू द वर्किंग, ठीक है, आज हम वर्किंग को कवर कर लेते हैं, देन विल consider the next in the tomorrow, okay, so working is working of the EDM. So there are like 3 to 4 mechanism we are using. First I'm just introducing that, then we'll go for the working part. So first mechanism, that is the DC power supply, okay, so this mechanism is nothing but the DC power supply we are using, okay, this is negative and this is positive side, negative side, this is the tool portion, this is the tool, okay, and this one is the workpiece, this is the container, okay, and up to this one the dielectric fluid is filled, means देखिए, by the way dielectric fluid we are feeding it, but we have to maintain something, okay, in between the workpiece and the tool, so we are maintaining that, okay, this level should be required, okay. Now this is the first mechanism, that is a servo, this is electric mechanism, so this is negative and the positive through which the power supply is initiated, DC power supply. This is the first mechanism. For the second mechanism, this is the main reservoir, okay, the bottom one, this is the main reservoir. Main reservoir means it is containing the liquid, okay, that dielectric fluid, this is containing the dielectric fluid, okay. Now dielectric fluid is filled inside that. Now by using the high pressure pumps we are just feeding it, okay, we are just feeding it over here. Okay, now this is basically the tool. Okay, so tool में क्या कर रहे हैं हम लोग initially, मतलब we are just using means a hollow section. Okay, we are just using means this tool is throughout from top to bottom is drilled. Okay, so this is, please keep in mind this one. Now if it is a drill, then it will be treated as a tube. Tube means in which we can fill the material, liquid material, we can pass through that. So this liquid, this dielectric fluid is passes through this one. Okay, this is coming from this side. Okay, now this is the bottom portion of this fluid. So now after coming over here, this will be dispersed in this direction and this direction. Okay, in this direction as well as in this direction. Okay, so यहाँ पे क्या होगा, ये आपका collect हो जाएगा. ठीक है. So now again there is a exit is there, that dielectric fluid can be exit from here, because otherwise आपका continuously आप उसको fill up करते रहेंगे, then it will be water will come out, dielectric fluid will come out from here. Okay, so we are using the exit mechanism over here. So through this pipe, this dielectric fluid is coming out, and we are using another reservoir. So this reservoir first is collecting this dielectric fluid, because now is the potential difference is created, and once the steady state condition will come, this will start releasing the electrons. Okay, and this will be releasing start the positive ions. So when whatever the principle that we have discussed till now, that positive ions will move toward the electron side, electrons will move toward the positive side, in between there is a molecules is there. So whatever the distance that we have studied over here, okay, whatever the distance that we discuss over here, this distance. Okay, now this distance is actually this one. Okay, this is very small. So whatever happening there, it is actually happening in very small area. So now when this spark is generated over here, okay, then this will be okay, so this spark is generated over here. So whatever the material that is removed, okay, because as I already discussed that kinetic energy is converted into the thermal energy. So when this thermal energy at high temperature will come in contact and remove the material from the tool and the workpiece area. Now whatever the material that has been removed from the tool and the workpiece, that will also carried out along with the dielectric fluid. Okay, so whatever the dielectric fluid that is coming out at this velocity at here, that is also coming out. So whatever the material that has been removed from here, that is also coming out along with that. Okay, so this is the working. Yogesh, yes, this class is daily. Yes, Yogesh, this class we have started from yesterday itself, and it is regularly. Okay, so now this material is coming out here along with the dielectric fluid. So why we are using this second reservoir, because this dielectric fluid plus this material which is removed from the workpiece area or the tool, now we are collecting that one. And why we are using the first reservoir, which is the main reservoir, because here we are using the filter. Okay, so dielectric fluid should be separated from the whatever the material that has been removed. Okay, so that's why we are using over here filters. So again that dielectric fluid is coming in the main reservoir, and we are using this again for the feeding purpose. Okay, so this is the main mechanism. Now there is one more thing is there, that when this one is this tool is the what initially there is a gap, and the workpiece and the tool like spark is generated, so now the material is removed. So there is a gap is increases. Okay, now if because अगर मान लीजिए कि गैप जो इंक्रीज हो गया है, अगर मान लीजिए कि स्पार्क अगर जनरेट होना होता तो इनिशियली लार्ज डिस्टेंस पे भी हो सकता था, बट वहां पे नहीं हुआ है. सो मिनिमम gap should be required. So what we have to do is we have to continuously move this tool towards the downside. Okay, so why? Because a constant gap is required. Please keep in mind that working of this VDM is complex because of this servo mechanism only. Okay, the feeding constant gap is required. Okay, now for this constant to maintain this constant gap, we are using the servo mechanism. Okay, this is the servo mechanism we are using. Fine. So whatever the I have written, this is basically the working of this. So whatever I have written, let's see this one. Controlled pulse generator is used with the DC power unit. Okay, so okay, that better we will discuss this one. I will tell you this part in tomorrow. Okay, why we are using this controlled pulse generator is used with the DC power unit. Why we are using? Because okay, I can tell you, but I will tell you tomorrow that about with the voltage and the current. Today, I just can say that we do not want the arc. We want the spark. Okay, so for that we need the pulse generator. Means for the some time we need the arc, after some time we do not need the arc. Okay, so this will be like fluctuation should be there of this arc. So that's why we are using this controlled pulse generator. Now how it will be, how this controlled pulse generator will affect the voltage and the current, that we will see tomorrow. Okay, now one more thing is there, that gap between the electrode and the workpiece increases with removal of the material. As I said that we have to use the servo mechanism. The power supply voltage is depends upon the spark gap only. Okay, that is also the main thing, that agar gap आपका increase होगा, then whatever the spark voltage that you are using through connect, that is coming through this supply, power supply, so that again an issue. Okay, so which needs to be maintained constant. Okay, so this spark gap should be you have to maintain the constant. Therefore a servo controlled feeding mechanism is used to sense the spark gap and make constant throughout the process. Okay, so now I think it's clear to you. So from in tomorrow session we will start this, what is the material removal mechanism. Okay, so thank you so much guys, and good night.